On August 13, 2026, Google announced Gemini 3.7 Flash. The release arrived exactly 22 days after the launch of Gemini 3.6 Flash. This creates a unique performance paradox. The new model beats its predecessor on every one of the 5 benchmarks published by the company, despite having only a 3-week development lead. The pricing is equally unusual. For the remainder of the year, this improved model costs 50% less than the version it is replacing. Google is framing this as their most intelligent workhorse model for coding and agents, yet they have introduced it at half the standard rate. Standard frontier AI deployment cycles don't typically move this fast or drop in price this sharply. To understand why, we have to look past the technical specs and toward the economic incentives. Agent harnesses are computationally expensive to tune and notoriously sticky once they are integrated into a production environment. Google is deploying this introductory pricing as a switching subsidy. For the next 4.5 months, the company is prioritizing workload acquisition over immediate revenue, incentivizing developers to retune their agentic workflows onto the 3.7 infrastructure. This subsidy window has a hard expiration date, December 31, 2026. On January 1, the introductory rates expire, and the per-task cost of maintaining those workflows will double. This mechanism explains the timing, the price point, and the focus on agent-heavy benchmarks. The math behind this shift is specifically designed for developers running large-scale agentic evaluation sweeps. The cost breakdown: 75 cents per million input tokens, $3.75 per million output. For SWE bench-style runs burning hundreds of millions of tokens, this significantly lowers the barrier to entry, creating a low-cost evaluation window through December 31. But builders setting customer pricing or budgets based on these rates are vulnerable. On January 1st, the price reverts to the standard rate, $1.50 per million input tokens and $7.50 per million output. That standard price is identical to the launch cost of the now deprecated 3.6 Flash. Any financial modeling built on today's launch numbers is subject to a 100% increase in raw token costs in under 5 months. Beyond the financial cost, the 3-week release gap establishes a new operational expectation. The model you spend weeks tuning your harness against today may become the deprecated baseline in a competitor's launch table by early fall. This channel covered Gemini 3.6 Flash just 22 days ago. The routing economics advice we provided then was superseded in just over 3 weeks. To stay ahead of these rapid frontier shifts with peer-level analysis, make sure you are subscribed. This cadence forces builders into a cycle of continuous retuning, where staying on the most cost-effective model requires constant engineering overhead. Examining the technical claims, we must interrogate the data behind the workhorse model marketing. This official 5-benchmark sweep reports 43.6% on Frontier Code 1.1 main and a 1,588 LO on WebDev Arena. But the most significant claim is DeepSWE version 1.1, where 3.7 Flash jumps to 65.3%, up from the 49.0% July baseline. A double-digit leap over an internal baseline can be a genuine breakthrough, but it could also mean that the original baseline was simply soft. Moving these models from evaluation scripts into live production introduces variables the launch post ignores. The announcement omits the 2 most important figures for a Flash class model: context window and latency. In agentic loops, chaining dozens of API calls compounds tail latency. Without a speed number, calculating the viability of these workhorse agents is impossible. While Google updated its safeguards for cyber offense, they said nothing about tool use guardrails for the autonomous loops they are encouraging. Marketing a model for agents while omitting speed and memory specifications is a significant operational oversight. To validate these claims, the engineering community must look for independent verification. The 3.7 launch table's credibility rests on third-party harnesses replicating the 65.3% DeepSWE score. If independent runs land within a few points of Google's figures, the objections to the internal baselines largely dissolve. If they land 10 points lower, the rest of the table becomes effectively unrateable. The final test arrives on January 1, 2027. If the price actually reverts to $1.50 per million input tokens, it confirms that this was a targeted switching subsidy. If a new 3.8 Flash model arrives before then with a fresh introductory rate, the lower price was never meant to end. It was simply a way to mask the long-term cost of the infrastructure. For now, system architects should ensure their routing logic remains flexible, protecting their margins from being locked into a single vendor's pricing and release cycle.